Hi there, welcome back to Pretty Much Flawless. Today in this video we are going to be starting a video series on designing a PCB that will fit into a DIN rail box like this. Let's get into it. It's a box from PCBWay. PCBWay makes high-quality custom PCBs for your projects. Design and upload your Gerber files to the website, then place your order and wait for your PCBs to come. And that's not all they do. PCBWay also does PCB assembly, CNC machining, 3D printing in many different materials, sheet metal fabrication, and injection molding. Check out their website. There will be a link to that in the description down below. Do you have a neat project or want to see some neat projects? Check out PCBWay Community. And if you are looking to make your own affordable PCBs, I would really recommend using PCBWay. And I look forward to using them again in the future. Alright, so we're here on DigiKey here. And what we're going to do is we're going to take a look at a DIN rail box, first of all. So what we're going to search is we're going to search DIN rail box. Go here to boxes. And then you can see we have a couple of different ones here, different styles. So what we're going to do is I'm going to take a look at this one over here. This is manufactured by Bud Industries, and this is the DMV4771. So let's take a look at the datasheet. Alright, so in this document here reveals all the different dimensions that we need to know. You can see this is what it's going to look like when it's all assembled here. So if we look down here, there's a couple different pieces here. You have your base, the mounting clip, and then you have the body, the two guards, and the cover. And then what it also shows here is these are circuit board A, circuit board B, and circuit board C. So you could mount 3 different circuit boards inside here for various functions. So your first circuit board A, would have your terminal blocks on it, and then circuit board B could be an extension to A if you need more room, and circuit board C could potentially be for indicator lights and that sort of stuff. What we can do is we can take a look at the dimensions needed for circuit board A and circuit board B and C. Right now, I'm just going to work on a circuit board made for circuit board A, so we'll zoom in on this. You can see here that it's supposed to be 50 millimeters wide, or 1.969 inches, and it's supposed to be 86.9 millimeters long, or that is 3.42 inches. And then here it also gives you a couple more dimensions for our screw terminals over here. So this shows that these are 5.08 millimeters, or 0.2 inches. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9 across this board here. And the distance is supposed to be 75.6 millimeters apart. So the reason why they specify this dimension over here for your screw terminals is, if you can see on the guard here, this is for the wire guard, there's also 9 holes along here. And if you use the 0.58 millimeter ones, this lines up perfectly with all of these holes here. I accidentally went ahead and ordered the wrong ones. These are from Phoenix Contact. These are 3 terminal blocks. And I accidentally got the 5 millimeter version, so it doesn't perfectly line up with these screw holes, which is going to be fine, but something to keep in mind. Another thing to keep in mind is the distance here. You want it to be this distance also, just so it's the right spacing. And yeah. And then you can also see circuit board B and circuit board C is also shown here. And also for all the different dimensions that you have is shown up here in section BB here, so we can zoom in on here a little bit more. So for circuit board A, we do have quite a bit of room. We can have components that are up to 1.134 inches tall. That is from the bottom of the board all the way to the top of circuit board B. If you don't have these circuit boards, you can go taller. In my case, I'm just going to be designing for circuit board A. But you definitely could design for circuit board B and C. Alright, so now what we're going to do, we'll jump over to KiCad here. And what we can do is go over here to the schematic editor. And what I'm going to do is I'm going to start laying out my components and make a schematic. Alright, so we have our circuit designed here, and basically what it's going to do is we have a ATmega 328P microcontroller here. This is the surface mount version, and we are going to have 6 voltage dividers across here, actually 7 if you count this one over here, and we are going to have 8 outputs over here, and these are 2N7002 N-channel MOSFETs, and they also all connect to these screw terminals. So for these screw terminals over here, I just went ahead and found on KiCad just a schematic for these screw terminals. These don't have a footprint, so we'll have to make a custom footprint later. I used 17 out of the 18 available terminals here. You can see pin number 3 on J1 is left unconnected. I didn't have anything to connect here. So what we can do now is we can design a footprint for terminal blocks. So we're going to take a look at the data sheet for our part here. So I bought the 5mm pins. So what that means is 5mm between the middle of this pin and this pin right here. And the box over here specifies that you use the 5.08mm pins. Again, should have got the other ones, but this will be fine. It's just going to be off by a little tiny bit, and these holes aren't 100% going to line up. Okay, so what we're going to do is we're going to go over here. This is the data sheet for our terminal blocks here. And what we're going to do is we're going to go down here, and we're going to take a look at our drawings here. So this shows us the hole size here. This shows us all the different distances and lengths that we need to know here for the holes. And then this also shows us what it's going to look like, how high it is, that sort of stuff. So what we're going to do is we're going to go over here to KiCad again, and we're going to open up and design a new footprint. Alright, so now what we're going to do is we're going to click create new footprint here, and we are going to, the footprint name, we'll do 9 times term block. And this is a through hole. This is a through hole footprint here. Okay, good. All right, the next thing we're going to do is we're just going to save this library here. So we'll click Control Save, and we're going to save this as a new library here. And it's going to be a project library. Okay. And we will call this here 9x term block. Okay, very good. All right, so now what we're going to do is we'll open up our data sheet over here. And what we can do now is we'll just take a look at our dimensions here. So first of all, for our hole size, we need this to be 1.3 millimeters. So what we'll do is we'll add a pad here, and we'll go in and we'll modify the settings here. So what we're going to do is we're going to go down to the hole shape here, and what we're going to do is we're going to change this to 1.3, and then we're also going to need to make some more copper. You can see what it's going to look like now. We need to adjust to have more copper to solder to, so you can roughly double this. So we'll go 2.7 just to give us a little bit more room to solder on. Okay, and we'll also double click on this again, and we are going to name this pad number 1. Okay. All right, so we have 9 pads laid out here, and we just double check that they're all the same dimension, which they are, which is good. And now what we're going to do is we're going to select them all, and we will click Align to Vertical Center. That way they're all aligned here. And now what we're going to do is we'll select them all here, and we'll click Align and Distribute, and we will click Align to Horizontal Center. So now they're all going to be in a pile right here. Now what we'll do is we'll click on this, and we'll click on pad 4 here, and I've adjusted our grid, so now we're at 5 millimeters, and we are going to move it 5 millimeters over here. Okay, now we'll do the same thing with pad 3, and we'll move this 10 millimeters over here. All right, so we can see that these are all 5 millimeters apart, which is very good. And now what we'll do is we'll just double check that our overall length is right also. Our overall length is 40 millimeters. All right, so next what we're going to do is we're going to work on our silk screen. So basically this is what we're going to see on the top of the pads just indicate where this part goes and how much room it's going to take. So you can see here that the overall length is 9 millimeters here, and then from the pin to the back end here, that's 4 millimeters. And also you can see from the middle of the pin over to the edge of the connector, that's 2.5 millimeters. All right, what we're going to do is we're going to make something 9 millimeters wide by 45 millimeters long, because basically we have 40 millimeters between pins 1 and 9, and then we add 2.5 this way and 2.5 this way. Okay. Okay, so now what we can do is we can just select all our lines here, and what we'll do is we'll maneuver this and try to get it right into the middle here. So what we have to do is we have to make sure it's 4 millimeters between the middle of the pad and the back end here, and we have to make sure it's 2.5 millimeters between the middle of this pad and this edge here. So we'll check that. All right, I have this 4 millimeters between the middle of the pad and the back of the connector, and then it's also 2.5 millimeters between here and the edge, so that's good. So we'll do. All right, so now what we can do is we can select everything, and we'll shift it over to where we want our reference. I think we want our reference up top here, and that looks good, so we'll save it. So now what we have to do is we have to assign our footprint for J1 and J2. So what we can do is we can go up here, click Assign Footprints, and for J1 and J2, we'll see here that says 9x term block. We'll click on this, and then you can see here we have in this library 9x term block. So we'll double click on this and double click on it again, and you can see this has been assigned, which is good. So we'll hit Apply, Save Schematic, and Continue. And then we'll hit OK. So that's good. Now the footprint is assigned. So now what we can do is we'll go over and we'll open up our PCB editor. And what we'll do is we'll say update PCB from schematic, update PCB, close this, and you can see all of our components are right here, which is good. So it doesn't really matter where we lay out our components on the board. The main thing is the two terminal blocks. So what we'll do, we'll take a look at our PDF file over here. You can see here that tells us the board needs to be 50 millimeters wide by 86.9 millimeters long. And then the terminal blocks have to be spaced 75.6 millimeters apart here. So what we'll do is we'll do that. So we'll select edge cuts here. We'll select the box. What we'll do is we'll just randomly make a dimension. And then we'll click on the box. And now we can type in our values. So if we type in 86.9, and then for width, we'll type in 50, 50. We'll hit OK. Now there is one thing we have to keep in mind, because KiCad, what it's doing is it's measuring from the middle of this line all the way over to the middle of this line. But the line width itself, we can double click on this and it'll tell us, is 0.05 millimeters. So what's going to happen is between the middle of this line and the edge of this line is 0.025 millimeters, so the same thing on this side. So when you export this Gerber file, it's going to think that your design is 0.05 millimeters larger than it actually is. So what we can do is we can just account for this by making this 86.85, and we'll make this 49.95. And that counts for when we export this Gerber file, that it's going to remain the right size. So what we can do now is we can lay out J2 and J1. I'll put J1 up here, and J2 we do have to rotate it. So we'll rotate it, and we'll bring it down here. Okay, so the next thing we can do is we can select all these, and what we'll do is we'll click Align Distribute and align to horizontal center. That's good. And now what we can do is we'll just take a measurement between the middle of this pad and the middle of this pad. I'll show you over here. And it should be 75.6 millimeters. Okay. All right, we have 74.6. So what we need to do is we need to increase this by 1 millimeter. Alright, so here we have it. We have 75.6 millimeters right from the center of this pad over the center of this pad, which is good. So open up our file and check to make sure that's right. It is right, that's good. What we'll do now is we'll select our two terminal blocks, and we will click on group. We'll click group items, and now what we can do is we can click on the box also and click align to vertical center, and we'll click align to horizontal center, and that's good. So now these are going to be right in the center here, and that'll be good. And now what we can do is we can actually ungroup these. We don't need these to be grouped really. Okay, so now basically what we have to do now is just lay out our PCB, just get all these things laid out nicely, and then that'll be good. Alright, so this is quite a bit later here. Basically you can see this is our finished PCB. So I have most power connections laid out on the top, and then I have most ground connections through vias onto the bottom. So this is good here. We have all our transistors up here, resistors here, voltage dividers here, voltage regulation circuitry over here. So that's very good. So we can export this as a Gerber file now, or if you have the PCBWay plugin here, what you can do is you can just click on this, and what it will do, and it will open up the PCBWay's website with our files uploaded. That's pretty nice. So we have our PCB file uploaded. We also have a bill of materials file uploaded, so we could add assembly if we wanted to. I plan to just hand solder this board. I'll make a video on doing that in the future. That will be part 2 of this series. Okay, so now what we can do is just go through and select all our different settings. So material settings, typically default is good for what I'm doing here. I'm going to change the solder mask to blue. And the great thing about PCBWay's website, if you don't fully understand one selection, they have a nice question mark here. So what you can do is you can hover your mouse over this question mark, and it will give you a brief explanation here. And if you click the Learn More button, then what happens is this will give you a more detailed explanation, which is great. Alright, 1 ounce copper is good. We're going to add a stencil to this board here, and we're going to make this a non-framework stencil. Now the difference between framework stencils and non-framework stencils is a framework stencil, they're typically heavier and bigger. They're used for machine printing. A non-framework stencil is better for hand soldering. So we're going to choose a non-framework stencil in this case. The stencil size is going to be on the top. The thickness is going to be 0.12 millimeters, and that should be good. Okay. So now we can save this to cart, we'll place our order, and the PCBs will be here soon. Thanks for watching this video today. I hope you learned something. If you did, please subscribe. That would really help my channel. And I'll see you next time.